So today we're looking at a new model from OpenAI that's available on ChatGPT, and this model is called O1. You may have heard of it before. OpenAI had released a preview for O1 in September of this year, a couple months ago. So they have two plans now, the Plus plan, and then there's also a new Pro plan, which they've just announced. If you have the Plus plan, you were previously able to use the O1 preview and O1 mini models. Now that these are fully launched, you have access to O1, but there are limits to how much you could use it. For most people, Plus is probably perfectly fine. Looking into the Pro mode, this new subscription actually includes unlimited access to O1, O1 mini, GPT-4o, and advanced voice mode. On top of that, they've released something called O1 Pro mode, which is going to give you even more power and reliability for more complicated tasks. Just to give you a quick overview of what these models actually are under the hood. So the O1 family of models, O1 and O1 mini, instead of just giving you an immediate response, they actually perform reasoning steps and they think through your problem step by step. They're a lot more intelligent. We can see that in terms of the benchmarks between these models. The O1 Pro mode and the Pro subscription for ChatGPT, they were both announced as part of OpenAI's 12 days of shipmas. December 5th, they are starting off a 12-day event. OpenAI is going to be unveiling a new product, feature, or demo every day. We can see that the day one release was the full version of O1, OpenAI's latest reasoning model, which is faster, smarter, and more accurate than its preview version. And then we also covered ChatGPT Pro, which is a new subscription tier at $200 per month. And that gives you access to an unlimited usage of all the different models in voice mode and Pro mode. So it'll be exciting to see what OpenAI has in store for the rest of this event that they're doing. A lot of people are anticipating a release of Sora, which is their text to video model. Seems like a pretty genius sort of marketing ploy. But today I thought we could go over the O1 models. The distinction between normal LLMs and reasoning LLMs like the O1 models, I like to think about it. There's a book by Daniel Kahneman, Thinking Fast and Slow, which I highly recommend. So Kahneman introduces two systems of thought. System 1 and System 2. System 1 is your fast, intuitive, and automatic response. Here's an example right here. 2 plus 2 equals 4. Reading text on a billboard, driving a car on an empty road. System 2, on the other hand, is slow, deliberate, and effortful for stuff like solving really hard math problems, like 17 times 24. This is an aside, but an interesting thing from this book is that it's so energy intensive to engage in System 2 thinking. You're not able to use System 2 thinking while you are engaged in heavy physical activity. It's just a fun little aside there. But yeah, I love to use this as my example to understand the differences between something like GPT-4o and GPT-O1, because 4o is System 1. You can see that in action if we go to ChatGPT. So we're on 4o right now. If I say, how do you make the color purple? So we can see that that only took 1 second to respond. It's just recall. So let's give it something more complicated to test out how good the response is. We can say something like, create a design document for a web app that is a clone of Space Invaders that includes cats. Cat Invaders, that's funny. So a web-based game inspired by the classic video game Space Invaders. Instead of alien invaders, the enemies are playful cats of various breeds. So we can see that this gave us a pretty decent output. Core gameplay loop, we've got the spaceship, cat invaders, the levels, power-ups. Now, what would happen if we use advanced reasoning? So let's try this out. You can instantly see the difference here is that it took a few seconds to think about it. If you click on this part right here, this is the chain of thought. It tries to summarize for you on the right here. This is formulating the structure, detailing the web app's high-level architecture, including the tech stack, game engine, and functionality. So let's try out that same response using O1 this time. But then let's say, please include code and the steps. We can see that took about 4 seconds of thought, which is a lot faster than O1 preview would have taken on this. 4 seconds is pretty fast considering it is writing 700 lines of code, eyeballing it. So what we could do is see if this output is any good. We could just copy the entire message. I'll take this design document and the code examples. I'll copy this whole thing right here. Then I'm going to go over to Cursor. So this is Cursor. It's an AI code editor. you can essentially have it write most of the code for you. So I'd say we're getting to the point where you don't even necessarily need to know how to code to be able to build some projects like this. Let's take that example. Let's see how far we can get without writing any code. So I've got cursor open. I've just created a new folder called Cat Invaders. And let's go over here into View Terminal. Open that up on the right here. In Windows, that'll open up PowerShell, just a command line where you can put in instructions and interact with your operating system. Let's go into these two tabs here. Once you open up Terminal, you'll also see these other two tabs, Chat and Composer. Okay, so chat would be like if you wanted to talk and ask questions about your code base. You can add context, you can add files here by searching the name or any contents, and then you can also go over to Composer. Now Composer can be opened up quickly with Control I. Chat can be opened up with Control L. So these are Windows shortcuts. So we can go and hit Control I to open the Composer here. And we'll see that right now it is using Claude 3.5 Sonnet. So let's swap that over to O1 preview, paste in the entire response from O1 preview, and let's say, you know, it says below is a comprehensive design document. After this, I'm just going to add a little thing here called instructions. Please implement this design, create the necessary files with the provided. You know, you have to say please in case AI takes over. So I always say please and thank you. Thank you so much. There we go. So now let's submit this. And then we will wait for it to generate. So you can see it's generating here. And the way Composer works is it will create a bunch of files and ask us to approve each change. We could potentially approve or reject specific parts of its proposals of what it wants to create, or we can just accept or reject the entire thing. It's up to us. Okay, so we've got an output now. Let's implement the Cat Invaders game by creating the necessary files with the provided instructions and code. Follow the steps below to set up the game locally. So it's gone ahead and created the game.js, which is the main file for the game code, JavaScript code, and then it has created the index.html. Yeah, we can see that it created the required files and then it adds the provided code to each file. You can accept this here, the individual file, or you can reject the whole file. You can also open that file here, and if it already existed and was proposing multiple changes, we could use these shortcuts to say yes or no. But we're just going to go ahead and accept all of these changes. So it should have given me instructions for how to open the game in our browser and start running it. I've got an extension installed called Live Server that allows me to just right click this index and open with Live Server. And that is going to open up this window. Cat Invaders, press space to start. Okay, I believe we won the game just then. That was really quick. Let's see if we hit refresh, we should be able to restart the game. So what happens if I get hit by that? Okay, we can see the game over. I got a score of 0. This is a good start. The fact that this works first shot is pretty cool. When I was a kid, I think it would have taken me the whole day at least. So it's just cool that, you know, we didn't write a single line of code. It was all just prompting. We were able to get a little simple game here. And the cool part about this is that if you do have any issues with it, we can have the AI fix the problem for us. Let's take this a step further, and let's say I want it to fire a lot less projectiles and I want a lot more enemies. Please reduce the frequency enemy projectiles by a factor of 10. There were so many coming out. And increase enemies with multiple rows and columns that move downward toward player. Also add destructible barriers at the bottom above the player. When all enemies are destroyed by the player, win screen should appear. Okay, enjoy your updated game. Enemies fire less frequently. Feature more enemies that occupy the top third of the screen. Destructible barriers. Win screen when all enemies are defeated. We can also adjust the rows and cat columns, and it actually has hyperlinks here, which is really cool because I can click on these and I can see what it's talking about here. We can see that it's using 6 rows and 11 columns. It added a draw barriers function, added it to the game loop. Now instead of running a next wave, it looks like it will just win the game. Okay, so these changes look good to me. Check collision with barriers for player projectile. Check collision with barriers for cat projectiles. I'm not going to read through all the code. It looks good to me, so I'm going to hit accept all and hope that it works. So let's see. Looks like the whole thing is now broken. This is a good example of debugging. Barrier width is not defined and barriers is not defined. Instead of fixing this myself, let's go ahead and give it these without any context and see if it'll figure it out. Looks like it just moved up barriers outside of this function so that it was no longer undefined. Added these variables here as well. Control S to save that. Let's refresh this. Let's hit start game. We are getting player projectile is null. So let's go in here and give it that information. Whenever the player shoots a barrier, we get the following errors. And we'll just wait for that. Accept, save. So when we save this, aha, okay. So it was able to debug it. And there we go. So now let's see if we can fix the offsetting. I've challenged myself not to write any code. So I'm gonna go back. I'm gonna say the enemies seem to be stacked on top of each other. Well, there's the code that was messed up. Before, it was just setting all of their positions, the X and Y coordinates for every enemy was being set to 0, 0, which is a pretty obvious bug. Now it's doing the column times the cat width plus the padding plus the offset. It should work. So I'm gonna hit accept and save and we'll see what happens. Space to start. Okay. That's actually, it's hilarious. It seems that it speeds up really quickly, so I think we lost the game instantly. Yeah, so they are moving down the screen at an insane pace. Let's just make that a little slower and maybe a little less enemies. That's quite a few of them. Because they were filling up the entire screen, they were only having to move over like 1 pixel before they changed direction. So it turned out that they were jiggling really quickly all the way down. This looks a lot better. It's a little too slow now, maybe. From 0.25, I'll probably change that speed. We'll make that 0.6, and then we'll make projectile chance right now as a frequency. Probably means that this is a 0.02% chance to make sure. So we could ask that question. We can say, what is the current probability for an enemy to spawn a projectile? 0.02% chance at each game loop iteration. So if we multiply that in a 1 second time frame, it does the math for us, and it says that there's a 1.19% chance for an enemy to spawn a projectile every second. It seems a little low to me. I'll probably make that like 5% chance every second, so that means that there'd be roughly 1 projectile from the whole lot of enemies combined every second. Change that projectile chance to be a factor of 5 better, so 5 times 2 is 10. There we go. Add iterations per second counter on the top. Turn the enemies into cat emojis. Okay, looks like it worked. That is actually cat invaders. Let's make the main character a dog. I think that kind of makes sense. Player a dog emoji. Alright, we're playing as a giant dog emoji that is just barely able to hide. I mean, all my barriers are gone already. So yeah, we were able to create a cat invaders game without writing a single line of code. I know we got pretty far without having to do anything. If you're interested in learning more about how to leverage AI, make sure to join our free community here. I'll be posting tons of courses in here, as well as the full-length version of this video. Thanks for watching.